In today's video, we're going to be discussing gypsum materials. So let's begin. Gypsum is a very soft mineral made from calcium sulfate dihydrate with the chemical formula CaSO4 2H2O. It is the second softest mineral on the Mohs hardness scale. And gypsum occurs in nature in two modifications, so it appears as calcium sulfate dihydrate and calcium sulfate anhidrate. Calcium sulfate dihydrate is monoclinic, whereas calcium sulfate anhydride is orthorhombic. Calcium sulfate dihydrate appears as selenite, which is transparent, flattened, and often twinned crystals. It also appears as alabaster, which is a very fine-grained white or lightly tinted material. Its hardness is 2 on the Mohs scale, whereas calcium sulfate anhydrate has a hardness of 3.5 on the Mohs scale. In dentistry, gypsum belongs to the group of laboratory materials. Its application is in the use of gypsum-based products in dentistry being widespread as an impression material for obtaining the impression and negative form of the patient's edentulous tissues. So a mixture of gypsum and water is used. It is placed in an impression tray and pressed against the tissues. After hardening of the plaster, the impression tray is withdrawn. It is also used for manufacturing of models. Another variety of plaster, dental stone, is mixed with water, poured into impressions, and allowed to set, forming a positive model. This model is used for denture construction without the presence of the patient, and also for gypsum dental investment. The plaster is mixed with fillers, different forms of silica. These materials are used to form molds of casting of dental restorations with molten metals. Dental plaster and stone. Plaster and stone products are produced by calcination of calcium sulfate dihydrate or gypsum. The gypsum is ground and subjected to temperatures of 110 to 120 degrees. It loses a part of the water, 75%, of crystallization, and dihydrate converts to anhidrate. When the dry plaster powder is mixed with water, it reforms into gypsum. A large gypsum deposit at Montmartre in Paris leads the gypsum to be commonly known as the plaster of Paris. Depending on the method of calcination, two different forms of the hemihydrate can be obtained: alpha hemihydrate and beta hemihydrate. Chemically, they are identical. The designations are assumed only for conveniences. The differences between alpha and beta hemihydrates are mainly manifested in crystal size, surface area, and degree of lattice perfection. So, beta hemihydrate or dental plaster has orthorhombic crystal system. They have large irregularly shaped crystal particles with capillary pores. And alpha hemihydrate or hard gypsum has smaller regularly shaped crystalline forms in the shapes of rods or prisms. There are three types of gypsum products. The various commercially available plasters and stones consist mainly of one of the forms of hemihydrate, small amounts of unconverted anhydrate, additional gypsum, dihydrate, and other salts to control the setting time and expansion. A large variety of dental gypsums exist. The main criteria for selection of any particular gypsum product is its usage and the physical properties necessary for that particular use. Dental gypsum is classified by the international norms ISO, ANSI, and ADA, and divided into 5 groups. Type 1. Gypsum for impressions. Type 2. Gypsum for models. Type 3. Hard gypsum for models. Type 4. Extra hard gypsum for dyes with high hardness and low expansion. And Type 5. Extra hard gypsum with high hardness and high expansion. As you can see, types 4 and 5 Also type 3 have very high expansion, but type 5 has the highest expansion of all of them. This shows that type 1 and type 2 are soft gypsum and used for plaster impressions and plaster models, but type 3, 4 and 5 are of hard gypsum, dental stone and special gypsum products. So impression plaster type 1. The composition, or it's known as plaster of Paris, to which modifiers have been added to regulate the setting time and the setting expansion. Impression plasters is rarely used anymore for dental impressions because it has been replaced by less rigid materials like hydrocolloids and elastomers. It is usually marked in the natural white colour, thus contrasting with stones that are generally coloured. Type 2 model plasters is relatively weak. Its composition is 90% calcium sulfate hemihydrate, 2 to 6% which is calcium phosphate dihydrate, and 3 to 6% which is calcium phosphate anhidrate. Model plaster type 2 is used to construct study models, to mount models on articulators, for preparing flasks for complete prosthesis. Dental stone. Type 3 gypsum is intended for construction models, thus must show good resistance to compression and abrasion. The main component is hemihydrate calcium sulfate, alpha with the addition of the appropriate additives. Dental stone type 3 is used for making full or partial denture models, orthodontic models, flasking procedures for acrylic dentures. It requires less water and is stronger than plaster. Type 4 gypsum is intended for the construction of models which must have a particular high resistance to compression and abrasion. It is principally used for the preparing of dies for fixed prosthesis. The main component is modified hemihydrate calcium sulfate with the appropriate additives. This type of gypsum requires a minimum quantity of water for mixing, and once set, it is the type with the highest resistance and density. Type 5 gypsum is always extra hard with high hardness for dies with higher expansion. Certain newer alloys have greater casting shrinkage than the noble metal alloys. Thus, higher expansion is required in the stone used for the die to compensate the alloy's solidification shrinkage. Special gypsum products developed for special purposes. A white stone or plaster for study models with surfaces treated with soap. These products have a longer working time and are easy for trimming. Mounting stones or plasters. For mounting the casts on the articulator. They are fast setting and have a low setting expansion and low strength to permit easy trimming and separating the cast from the articular mounting plate. Dental stones. Extremely fast setting and ready to use in 5 minutes, but with little working time. Dental gypsum, which changes colour to help denote when it is ready to use. The setting of gypsum products. The calcium sulfate hemihydrate is the starting material used for the production gypsum casts, models, casting investments, and impression plasters. The reaction describes the reaction of calcium sulfate hemihydrate powder with water to produce gypsum. The reaction is exothermic and the heat evolved is equivalent to the heat used originally in calcination. The setting reaction. These are the proposed theories. The colloidal theory is when mixed with water, plaster enters into the colloidal state through a solid gel mechanism. In the salt state, hemihydrate particles are hydrated to form dihidrate, thereby entering into an active state. The hydration theory is where rehydrated plaster particles join together through hydrogen bonding to the sulfate groups to set material. The dissolution precipitation theory, which is the most widely accepted, is based on the dissolution of plaster and instant recrystallization of gypsum, followed by interlocking of the crystals to form the set solid. According to this theory, the setting reaction of gypsum occurs by the dissolution of calcium sulfate hemihydrate, the formation of a saturated solution of calcium sulfate, and the subsequent aggregation of less soluble calcium sulfate and dihydrate, and then the precipitation of the dihydrate crystals. The reaction is continuous and continues until no further dihydrate precipitates out of solution. The amount of water and hemihydrate should be gauged accurately by weight, so that water to powder ratio expresses the ratio of the water to hemihydrate powder. The water to powder 0.6 is where 100 grams of plaster is mixed with 60 milliliters of water. The water to plaster ratio 0.28 is where 100 grams of dental stone is mixed with 28 milliliters of water. The water to powder ratio is an important factor in determining the physical and chemical properties of the final gypsum product. As the water to plaster ratio increases, the setting time also increases, the strength of the gypsum product decreases, and the setting expansion decreases. The mixing time. This is the time from the addition of the powder to the water until the mixing is completed. Mechanical mixing of stones and plasters are completed in 20 to 30 seconds, and with hand spatulation it takes at least 2 minutes. The working time, which is the time available to use a workable mix. It is measured from the start of mixing to the point where the consistency is no longer acceptable for the product's intended purpose. Setting time. This is the time that elapses from the beginning of mixing until the material hardens, usually measured by some type of penetration test. The loss of gloss test for initial set. As the reaction proceeds, some of the excess water is taken up in forming the dihydrate so that the mix loses its gloss, about 9 minutes after the beginning. The mass still has no measurable compressive strength, and it could not be safely removed from the mold. The Vicat test for setting time. A Vicat penetrometer is used to measure the setting time of gypsum products. After the loss of gloss, the plunger rod is released onto the mix. The setting time is the elapsed time from the start of the mix until the rod no longer penetrates the bottom. The Gilmore test for initial set. The Gilmore needle is used for determining the initial set of gypsum. The mixture is spread out and the needle is lowered onto the surface. The time at which it no longer leaves an impression is called the initial set. The Gilmore test for final setting time. The next stage in the setting process is measured by the use of heavier Gilmore needles. The elapsed time at which the needle leaves only a barely perceptible mark on the surface is called the final setting time. And the ready for use criteria. It's a subjective measure. It's the ability to judge readiness of gypsum to be handled improves with experience. Technically, the material is considered ready when the compressive strength reaches 80% of the strength attained after 1 hour. Most products are ready to use in 30 minutes. A clinical tip is before separating the cast from impression, ensure that no part of the tray is connected to the gypsum. If alginate impression dries before the cast separation, soak in water for 15 minutes. Control of the setting time and expansion. The control can be achieved by 3 methods. The solubility of the hemihydrate can be increased or decreased. The number of nuclei of crystallization can be increased or decreased. And the setting time can be accelerated or retarded by increasing or decreasing the rate of crystal growth, respectively. Impurities. The remained gypsum particles shorten the setting time because of the increase in potential nuclei of crystallization. Fineness. The finer the particle size of the hemihydrate, the faster the mix hardens. The water to powder ratio. The more water for mixing, the fewer nuclei there are per unit volume. So, mixing. Rapid and prolonged spatulation, accelerated setting, and also increases setting expansion. The crystals are broken up by a mixing spatula and are distributed throughout the mixture, resulting in formation of 1 or more nuclei for crystallization. Temperature. Increasing water temperature to a certain level will accelerate setting. If the temperature of the plaster water mixture exceeds 50 degrees Celsius, a gradual retardation occurs. Accelerators and retarders. Manufacturers add accelerators or retarders to gypsum. These chemicals increase or decrease gypsum solubility respectively, which will alter setting time accordingly. Clinicians can add accelerators such as potassium sulfate or set gypsum. They act as sites for crystallization. Setting reaction retarders, for example blood, saliva and alginate, if left on impression, can affect surface details of the impression. Impression surface needs to be properly rinsed before being poured. Setting expansion. The setting expansion of the gypsum product is due to the crystallization process. The structure immediately after setting is composed of interlocking crystals, between which are micropores and pores containing the excess water. On drying, this water is loose and the void space is increased. The volume and linear changes are highest up to 1 hour after setting and continue up to 24 hours. Linear expansion of gypsum is 0.1 to 0.3%, and in some cases, setting expansion is an advantage of gypsum because thus the contraction of the other materials can be compensated. The setting expansion can be reduced by adding chemical materials, for example borax or potassium sulfate. If we add potassium sulfate, the expansion will be decreased, but the setting time will also be decreased. It means not enough working time. In order to prevent this great decrease in the setting time, the borax also has to be added. It will decrease the expansion but will increase the setting time. If the two materials are added together, the final result will be decrease in the setting expansion and decrease in setting time, but not as much if it was potassium sulfate alone. This is the lecture on gypsum. The next video will be on metal alloys in the dental field, so make sure you subscribe and thanks for watching.